Hello, on this video I'm going to demonstrate or actually investigate how the frequency of the master of oscillator of Kenwood 590SG deviates from the moment that you will turn it on until it starts to warming up and comes into a stable operation. We all know that the temperature of the system inside the device is actually affecting the frequency of the master of oscillator that actually determines where exactly the receiver is tuned during reception. For this reason, I'm going to use the FLDigi as an instrument which will help me to check where exactly the master oscillator is resonating. And I'm going to tune the 590SG into a world clock frequency at 10 megahertz, which is transmitting a constant CW tone. On a previous video I have shown how to open up the rear cover of this transceiver and with the help of a screwdriver tune the master oscillator to the exact frequency. I have done this and now I'm just wondering how much is the drift or how stable the master oscillator is close to the 10 megahertz frequency that I have calibrated on my previous video. Okay, the machine is off. I'm going to switch it on 10 megahertz CW mode, and I'm going to see on the FLDigi what exactly the audio pitch of the CW tone appears on the FLDigi. The pitch tone has been set to 1 kilohertz, so I'm expecting to listen a 1 kilohertz audio signal when I will be tuned on the 10 megahertz wall clock. So let's switch this on. Right. Okay, let me check the pitch tone. It's 1000. Okay, now I'm going to the FLDigi and see where this thing is actually the audio tone is heard. Okay, on the top left of the display on the FLDigi is 10,000. Okay, let's zoom in here and see. Okay, so it's here. Right. So the audio tone, it's according to the waterfall just below the 1 kilohertz frequency, and this is let me just check it there. This is 970 hertz. So I'm just 30 hertz off. When I switched off the transceiver, it was exactly at 1 kilohertz. The last time I switched it off, it was a few days ago, and now it's 970. Can you see that on the video? Oh no, it's not so clear, is it? Oh no, it's there. Okay, 970 hertz. So I'm 30 hertz off, but I can notice that it's now a little bit off again. So this is because the transceiver is warming up. Okay, now it's gone to 975. Oh, it's not visible on your on the tablet. 975. Oh, my apologies, it's not shown there, but it's 975. Okay, So I'm going to stop now, and I will be back in 5 minutes to see if there is any further drift. And I will be repeating this experiment for the next 30 minutes and see whether the audio tone will actually settle down to 1 kilohertz as it was calibrated during my tuning, during the tuning of my master oscillator. Okay, so I'm going to stop now and I'll be back in 5 minutes. Okay, so we are now 5 minutes. We are 5 minutes after I have switched on the Kenwood transceiver, and let's see where the audio frequency of the wall clock is located right now. Okay, so it's over here now. This is 984 hertz. Oh, can you see that? Oh, it doesn't come up. Okay, 984. So it has been drifted once again, but towards the 1 kilohertz tone. So it seems that the warming up is actually helping a little bit, and hopefully we are going to get closer to the 1000 hertz later on. Okay, so let me just write down the things. So the tone frequency of the wall clock at 10 megahertz. When I switched on the Kenwood, it was on a 970 hertz, and 5 minutes later it's 984 hertz. So let's wait another 5 minutes and see whether the tone of the wall clock will come closer to the 1 kilohertz target signal. Okay, so we are now on the 10th minute. Yes, since I have switched on the transceiver. Let's go to the FLDigi and see where the pitch frequency is located right now. So okay, it's been drifted a little bit towards the 1 kilohertz. Okay, let me center the mouse on top of the main line, and this is, oh, it's not visible again. Okay, it's 987 hertz. Okay, so let's write here 987 hertz. Okay, it's closer to the 1 kilohertz tone, but I feel that it's still far away in some ways. And also I can see here on the waterfall a kind of harmonics on the left, on the upper and lower side of the main tone, and maybe this is because I'm now overdriving the sound card of my computer. I'm not so sure about it. Maybe I need to reduce a little bit the microphone level. Okay, maybe I'm overdriving a little bit. Oh no, that's too. Okay, I cannot set it. Okay, now it's off. Minus 190 dB. This is like switching off the microphone. 3.9 minus 10. Okay, I don't know what's this, but anyway, I'll take care of it another time. Okay, so I'll see you in 5 minutes again. Okay, so we're 15 minutes running time. Let's check where the audio signal is. Okay, it has gone a little bit to the right compared to the previous 5 minutes. Okay, so this is there, and that's 990. Okay, so it's getting there, but slowly as the time goes on. I guess it follows a kind of exponential curve. It takes longer and longer to come closer to the 1000 as the time goes on. Okay, so we will be back in 5 minutes. Okay, so we are 20 minutes after I have switched on the transceiver. Okay, let's see the waterfall display on the FLDigi. Okay, so we are on the 991. Okay, this is 991. 991 hertz. Okay, so it hasn't drifted much really. So it seems that it's going to settle somewhere near this 900, maybe 95. Okay, let's see. Okay, so I'll see you in 5 minutes again. Okay, so we are on the 25th minute, and see where the audio tone is located right now. So it's okay, it has gone a little bit to the 1 kilohertz. Okay, it's there. This is 994. 994 hertz. Okay, so it seems that there is still some drift taking place due to the warming up. Okay, I'm going to wait another 5 minutes. So we're on the 994 hertz. Let's wait another 5 minutes and see if there's going to be any more change. Okay, so we're 30 minutes after we have switched on the transceiver. Let's see where the audio frequency is located right now. So, it shifted maybe 1 or 2 hertz to the right. Okay, let's try to center it. Okay, this is 995. This is 995. Okay, it's been 1 hertz higher. Okay, so we're just 5 hertz off the desired frequency, and I can suspect that maybe the transceiver will drift a little bit more, just a little bit maybe, towards the 1 kilohertz line. But nevertheless, we got an idea of how the master oscillator is drifting after a cold switch on. So maybe if we use a transceiver for SSB or CW, we are going to see a higher temperature on the case, and this is going to push the local oscillator a little bit higher, since we have a positive coefficient on our tunings. Okay, so I will stop here, and hope you got an idea of how maybe the transceiver behaves after warming up and being on the receive mode. Okay.